So we thank Professor Brian Tanner from the Physics Department of Durham University very much for providing a summary and his thoughts on the proceedings of the day.
Well, thank you very much indeed for coming back. I was expecting everybody to have tea and then head straight out, so I'm very grateful. I come to this meeting as a career physicist who, as is the case for many elderly physics professors, we turn to the history of science in our dotage. And I've been, in the last few years, very closely involved in the Ordered Universe project, which is an interdisciplinary project. There are another 3 members of the team here today, looking at the scientific works of Robert Grosseteste. So I came to the meeting from a point of view with a little bit of expertise on Grosseteste, and huge great gaps in my knowledge. We've had a super day in that we've had stories about people, we've had ideas relating to thought processes. But what I thought I would do would be just to go straight back to the conference objectives and just let you have a think about whether you've got any of those objectives that you would regard as achieved. I think this challenge to the commonly held view that there's this great gap in Western civilization's understanding of the natural world is something that we've certainly seen it's not true. There has been a continuum of thought. The type of thought has actually been different. We've reviewed the contributions of medieval scholars, and in particular looking at the way their activity has evolved. So I think, Joanna, you should regard that as being a very successful conference. And I would like to thank the speakers for actually achieving that. Some of the thoughts that I've had during the course of the day, and I've made lots and lots of notes, so things that have struck me is just how heavily based on the Greek and Arab antecedents has been the whole medieval enterprise. And that came through in virtually every speaker. The contribution of Oxford to the 13th century does depend rather on the chronology, and I think that came out in Jack Cunningham and Brian Clegg's talks, that if the chronology is a little bit different, then maybe Oxford doesn't take quite as much credit. And as an Oxford alumnus myself, of course I want the credit to be there, so I move to the right. No, I don't, I move to the left. I think there was a challenge to 2 of the speakers as to what scientific contributions were actually made by these scholars. What new science emerged? Yes, new thought processes emerged, but what new science emerged? And there are examples. Grosseteste's work on colour, his work on sound, his work on the rainbow, these clearly are genuine developments of science. But I think that is a challenge that I wasn't quite totally convinced was from our colleague at the back, that challenge. I wasn't quite convinced that that was there, and maybe that's something we need to think about. Bacon's argument that science was essential prior to the study of theology interested me. and also the fact that there was no contribution to technology or practical application. But the science was clearly influenced by technology, and I think Alan Chapman's comment there what was really quite interesting, and I thought that was... so we normally see science and technology as being interlinked, but in this period almost the technology is driving the science rather than the other way round. I'm sure that view is also open to challenge. In looking at Grosseteste, he was very concerned with unification of understanding of natural phenomena. His light metaphysics was designed to explain why solids have dimension, and also to explain the whole structure of the formation of the universe. He linked sound and light. He linked the theory of colour and the theory of the rainbow. He linked the theory of refraction and the theory of the rainbow. That unification, did that come through? Well, yes, I think it did. The harmony of science and theology came through in James Hannon's talk. That came through in the whole of the proceedings, that science and theology were not in any way opposed. There may have been tensions between the faculties of science and theology, but nevertheless the harmony of purpose was very clearly there. The links between Oxford and Europe also came through, that this was not an enterprise just in one individual place. People were travelling much more in the medieval period than we tend to give them credit for. Jack Cunningham, talking about my hero, talked about the uniformity of nature, that nature operates in the most efficient way possible, and that light is the first form. So this unity, this looking for causes that are interrelated, is something that I think came through in the whole enterprise, and that's what I see as being the medieval physics. If I look at methodology, again, Grosseteste made some contributions here, of which Jack told you some of these. He argued that pure suppositions and premises were best. That, of course, has been claimed by William of Ockham subsequently, but that's Oxford again, so we're fine. He developed the method of reducing a complex and intractable problem to simpler, tractable components, and that is a feature of science that we have taken with us all the way through. So that development of a methodology, I think, was really very important. So where did we see that in the course of the day? The development of the use of mathematics to explain the natural world does appear to be a major development that, amongst other places, occurred in Oxford over the period we've been looking at. The application of mathematical instruments to reach quantitative conclusions were beautifully demonstrated to us by Alan Chapman, and again, the operation in a technological culture was something that I found interesting. It hadn't occurred to me that the first treatise on how to use a mathematical instrument was that of Chaucer, but that was another good one. And the question of experiment in the medieval period was raised by Jack Cunningham, and is something that I find really quite challenging. For example, in the De Ride, the treatise on the rainbow by Grosseteste, he describes this well-known experiment where you put a coin in the bottom of a vessel and you stand just so that you just can't see it, and then you pour water in, and lo and behold, at the same angle you can see it. The interesting thing is that Grosseteste describes this, and he quotes from an earlier source in good medieval tradition. But if you look at a later copy of that work, you find that it is not from which the object cannot be seen. It actually refers specifically to a coin. So somewhere along the line, somebody did do that experiment in the medieval period. So this question of experiment and experience, and I would remind you, as I keep telling everybody, that the modern phrase that the French have to do an experiment or to have an experience is effectively the same. That word the French use is common to both experience and experiment as it translates. And I think this is something that still requires a little bit more examination. I don't think that I would go along with Crombie in totality, but I would love to get somewhere along the road. For example, Grosseteste took law of refraction, in which the refractive angle is half the incidence angle, and he argued it from a point of view of simplicity. He clearly couldn't have done the experiment because Ptolemy had done it. Alhazen describes it, and Witello also describes it later on. And actually, if you look at the data, it fits the modern Snell's law really very beautifully. And I'm afraid our friend Grosseteste is not in terribly good shape there. But nevertheless, what evidence is there for precise measurement? And that didn't quite come through as to just how the sort of philosophers, what experiments did they do? And I think there's some work there which might well be done to try and dig a little bit deeper in there. I thought that point about the role of funding of science came through really very beautifully. The idea that you need leisure and time for thought, which costs money. And Richard of Wallingford, well, what a guy. The legacy? I'm not quite sure that we saw the legacy so much. If you look at the legacy of the rainbow, Grosseteste, Roger Bacon, Witello, Dietrich de Freiberg, and onwards. Some of the other legacies maybe didn't come out, and maybe again that's something we might want to examine another time. But the point that Nicholas gave right at the end about anachronism, I think ought to be the take-home warning. That in understanding medieval science, it must be understood in the context of its time, and we must not superpose a modern worldview as the Victorians appear to have done, though that's superimposing our worldview on the Victorians, of course, and seek to identify discoveries ahead of their time. Those are the things that I shall take away from what has been, for me, a fascinating conference. I'm incredibly impressed with the size of the audience. It's been a super day, and I hope that that just acts as a way of sort of wrapping things up. I don't know, Pierre, whether you want to have a few questions for any of the speakers or even me at the end. But
well,
you're
thank
the
you
chair.
first. Thank you for
And I didn't have any tea because I wrote those slides. Or some of them, anyway.
Thank you.
I'm putting off
It's
now.
all worth it for getting your experience as an experimental physicist. So thank you very much. Are there any questions for Brian or any of the other speakers?
Just a hope. Can we expect any sort of publication?
Okay, the videos will be online, so no publication.
On YouTube?
On the college website.
So this is not a question, it's just a thank you. I thought that summary was actually quite useful, and you picked up points that I hadn't sort of thought about in so much detail, and I'd just like to thank you for that. I thought that was good. Thank you.
Just on the note of publications as well, I've just somebody reminded me that I was the only person today who spoke and didn't plug a book. Well, there is a book coming out by Springer very, very soon, and it includes chapters by many of the people who are in the audience today, particularly those associated with the Ordered Universe project. It's called Robert Grosseteste and the Pursuit of Scientific and Religious Learning in the Middle Ages. And I think it encapsulates an awful lot of what went on today. So there's my plug.
Thanks for a fantastic summary. I thought you must have had advance notice of the papers. If you did that in your tea break, that's remarkable. And you've partly destroyed what I was going to argue, namely that Oxford no quack. Let me try and salvage what I was going to say. If there were any points, it seems to me there were Grosseteste's refraction theory, to which my instant response is, that's Lincoln, that's not Oxford. I don't know when he did that.
He certainly didn't do it when he was Bishop of Lincoln.
Okay.
The scientific treatises come before his period as tutor to the Franciscans in Oxford.
Right.
Was he in Oxford when he wrote those? Depends on Jack's chronology.
Okay.
He probably was.
Midway between them.
All right.
And the other point I got was the Mertonian mathematics of uniform acceleration, which is pure kinematics. It's not physics. They correctly didn't describe gravitational freefall as uniformly accelerated because, of course, it's not. It's increasingly accelerated. So they were good to do that, but that's arguably not a contribution to physics.
I would agree with that. The reason I didn't include that point is because it had already gone into my subconscious and didn't quite come through. But you're absolutely right.
Okay, so just let me run through some key points about where the developments were. I mean, the first sentence, I think, is correct on the summary you put up. There wasn't a gap. The modern theories are the result of the centuries of empirical and theoretical work. And I'm sort of an extreme Duhemian continuist, even more continuous than Duhem, that the theories we're talking about here, which are the theories of mechanics and gravity, as well as heliocentric theory of the solar system, I hold that the theory of mechanical Newtonian dynamics is in fact the result of a continuous development of Aristotelian dynamics and a form of it by commentaries on Aristotle's physics and criticism and refutations and conjectures and law refutations in a kind of dialectical development. But Newton still maintaining that every motion requires a moving force. Uniform motion requires the force of inertia. So he's an Aristotelian on that standard conception of Aristotelian dynamics. The basic thing is to have a mover. So on the those developments, I put them, a lot of them outside universities altogether and not in Europe, in Arabic traditions. Those not in universities that I think are important are Averroes, in developing the theory of inertia as a resistance to motion of all bodies, and Al-Barakat of Baghdad, who I think developed the theory of impetus dynamics that went on to Paris with Buridan. So that's non-university developments. Outside of Europe, I should have said those people weren't in universities. They were at courts and caliph courts and things like that. Outside of Europe, yes, again, Barakat. I think that's the problem there is the neglect of Arabic developments, which the standard history is the Arabs are just porters who bring across ancient Greek stuff and everything and don't develop it, where in fact they make two crucial developments, as I've said before, in impetus dynamics, which leads to momentum, and theory of inertia, which leads to the idea in Newton, who modifies it, that bodies resist accelerated motion. So there's some fundamental concepts that I think are not part of the standard history. And I'd also finally just say, even Newton himself, in an unpublished paper, attributes his own first law of motion to Aristotle, Physics 4.8, in which it's the major premise of Aristotle's refutation of the void. So that's my sort of challenge to think about, maybe, where the developments weren't, important developments weren't at Oxford, but were in all sorts of other places, not necessarily in universities, not necessarily in Europe. Okay.
Actually, it's a comment, but is a question at the end of it. I thought it was very impressive when Grosseteste said light is the fundamental physical substance, because obviously we know now that light has got energy, and energy is equivalent to mass. So that seems sort of very sort of prescient in a way. It seemed very impressive. But then I was slightly disappointed later when the speaker referred to Genesis, and he said, "Let there be light." And so then I think, oh, well, is that where Grosseteste got it from? But the question then is, was in fact the person who wrote Genesis the first astrophysicist?
What's interesting, I think the treatise on De Luce does not refer to God. So he does not state anything about Genesis in that treatise. He simply starts with, I say that that light is the first corporeal form. And he doesn't invoke Genesis at all. He just looks at the consequences of this suggestion that light and matter are intimately bound, and if light expands at infinite speed, instantaneously in all directions, what are those consequences? And then he actually not only gets to the size of the universe, Jack didn't then mention that you then get light which continues to multiply, which pushes matter back in again, and he forms the Aristotelian heavenly spheres on that model. To which, as part of the ordered universe workshop, the physicists, the three physicists in the room, said, hey, that argument is so tightly argued, we can write that down in mathematics. And we did. And then we said, but now we can use mathematics, we can use a computer to solve it. And that turned out not to be quite so simple, because that's fine when you're solving these equations. Implosion is a different matter. A supercomputer later, we did indeed solve the Grosseteste equations, as we call them. The model works. It's brilliant. There's a paper in the Proceedings of the Royal Society. Was it last year or the year before? I'm losing track of time. It's the year before, in which we just showed that this model did in fact work.
It was handy. We have the Institute for Computational Cosmology and the supercomputer that goes with it up in Durham at our disposal. So,
are there any other questions?
I thought we might be in the earlier medieval period.
So one of the things I was reading on the way here was the Anglo-Saxon Chronicle and Bede. And I was wondering, have I understood correctly that the Enlightenment moved to looking at physics in a more rational way came with the translation of Aristotle following the events in Spain? Was that the turning point? Because what's to be found in their essay on astronomical and atmospheric events is, a lot of superstition and so on about the red moon and then the bishop died of pestilence and so on, and flying dragons. So was that the turning point? Was the translation of Aristotle in Spain?
I think there are people in the audience who are much better qualified to answer that from me. I, of course, am a great fan of the Venerable Bede, who was the first English scientist as well as the first English historian, and I think that's another good example of unification. But somebody else ought to pick that one up. Sorry, did you want to comment? Yes, you. No.
I'm a physicist, not a historian.
Yes, the same goes for me. And I certainly don't know about Aristotelian physics and Bede, but I've just read the mathematical puzzles of Alcuin of York, and they're certainly very sketchy in places and read very differently from Robert Grosseteste's stuff. So I guess there's definitely been an influx through the Arabic translation movement. Any other questions? So if not, let's thank Brian again for a brilliant summary.